Good morning, everyone. We'll get started here in just a second. Okay. Okay, everyone. So just in case you did not attend class last time, exam 3 has been moved to Tuesday of next week. We covered last time rational functions, so that's old. Today, all we're going to do is review, and then we'll have our exam on Tuesday. So make sure for the exam, let's get this stuff out of the way first. For the exam, I'll do this on today's notes. You may use one 8.5 inch by 11 inch. I'm going to call it a reference sheet. Now on this sheet, you can do front and back. Okay, you can write it out, you can print it, you know, type things up on your computer. It doesn't matter how you do it. Just has to be a single standard sheet of paper. Front and back is allowed. And on that, you can have, you may put formulas, steps, processes, anything you want that will help you get through sketching of parabolas, sketching of polynomials, and sketching of rational functions. So just go back and review your notes, make sure that you have everything on that reference sheet. And then you're also going to turn that in, all right? So you will be submitting the sheet with your work. Okay, so when you turn in your exam, remember you're going to do it just like we've been doing. You take pictures, you're going to send me the file in that Dropbox and everything. Just put your reference sheet as your last page or your first page. Just make sure it's in there. And if you do both sides, make sure I can see both sides. And that's just to be fair, make sure everyone was you know, within the parameters of what was allowed. Very important. You may not know worked out problems. Okay, so if I look at your reference sheet and I see that you have examples done, worked out, then that will, I won't give you a 0 on the test, but I'll penalize you. And my whole idea with that is you should not be able to get a higher grade than anybody else in the class. So whatever the lowest grade is, your grade will be lower than that. So just make sure that you're following what I say here. You may put formula, steps, any sort of process there. Any questions on that reference sheet? Make sure you make that before the test, right? I'm not going to give you 15 minutes in the beginning to write everything down. Come into the test with that sheet. And then, of course, you'll have to have your cameras on and you'll have to be set up properly. It's the 3rd time we've done this, so I'm not going to be very compassionate when it comes to this. Get yourself set up. Make sure I can see your whole workspace and what's in front of you and everything else. All right. I don't have anything else in terms of the details of the exam. I want to get into the review now. So I gave you a bunch of problems to work on here, kind of examples. And I realized after I did this that I did forget to include a problem about an object that's been thrown into the air and trying to figure out, you know, its highest point and how long it takes to hit the ground. So I'll try and throw that in here, but I would expect to see something like that on the exam. So first, I'll start with any questions, like, do you want me, for those of you who went through this review, is there one in particular that you want me to address first to make sure that we get through it? Because I don't know if we'll get through all 7 of these.
I have a question.
Okay.
It's not for like a specific problem, it's kind of like a general question, but
Right.
it's for the polynomials. And I was just wondering what number determines if we cross or touch?
Okay, so the thing that determines that is the power on the factors. So you have to get your polynomial into a factored form first, and then you look at each of the factors and you look at the powers on those, and that what will determine touching or crossing. It'll
Okay.
cross if it's an odd power, it will touch if it's an even power. So I think when we do an example, I'll make sure I stress that point when we get to it. But that's, if you're asking me just generally, that's the answer.
Okay, thank you.
Uh-huh. So do y'all want me to work on anyone in particular, or should we work, backwards? Should we just start with number one? What do y'all want to do? This is your day.
Can we work on number 5?
Yes. Okay, we'll start with 5. We'll see if we can knock these out, all right? So let me see if I can grab this thing. And let's get to today. All right, so I guess the first thing you have to know here, and the instructions here are to sketch this, all right? So the first thing you need to know is that we're looking at a polynomial function. And I think that is obvious because, well, it's not quadratic, right? The highest power of x we see is not 2. And it's not a rational function because it's not a fraction. So there's only 3 things I'll be asking you to do in this test: parabolas, polynomials, or rational functions. So this is a polynomial for sure. And that means we need to go through the steps. Now, I don't want to go back in my notes and look for the steps. I'm assuming by this time you have them, you know them, you've maybe written them down. So can somebody tell me what the first step for sketching a polynomial function is?
We can't see.
Can't see what you're writing. We just see your home screen.
Really? Oh, I didn't know that. I'm sorry. You haven't been able to see me at all this whole time?
No, sir.
Oh, okay. Let me try again. Oh, it was grabbing my other screen. Oops, I'm sorry. Okay, can you see the problem written down or no?
Yes, we can see now.
That's really weird. That's the first time it's ever done that. Okay, so let me go back real quick. I had typed this all out for you, right? You may use, I just want to make sure that's on screen so everyone sees it. Okay, and these were the problems that I gave everyone last time. I'm glad y'all said something finally. Okay, so we're looking at this. It's a polynomial. First step is to do what?
Determine if it opens up or down.
Okay, sure.
Oh,
No, it's okay, Patrick. You just gave me the first step for doing a parabola.
I'm so sorry. Yeah,
No, don't apologize. This is where we need to make sure that if we're going to make any mistakes, this is where it needs to happen, right? Not on the test. So because it's a polynomial, Patrick, look back in your notes to see, I don't know, maybe someone can help us here.
The degree for the end behavior.
Yeah, okay, so here it is. Here's how to sketch polynomial function. Use the leading coefficient test to determine the end behavior, right? So that means I'm going to look at the degree of the polynomial, which is 5. I'll just write that down. The degree is 5. And then the leading coefficient is the number in front of that, which happens to be a 1. And then again, going back to our notes, we have to use this table, which you definitely should have on your reference sheet. This tells you how to determine the left and right behavior based upon whether or not your degree is even or odd and the leading coefficient is positive or negative. Here, our degree was odd, right? It was 5. So we have an odd degree and we have a leading coefficient of 1, which is positive. So we're going to be the green thing here. That's what our graph should look like. So that means that we know the left side goes down and the right side goes up. In the middle, we don't know. There could be a bunch of weird stuff happening. Okay, good. Who's got the second step?
I got it. Okay, so it says Find the x-intercept and see if it crosses or touches at each one.
Yep. Okay, so how do we find the x-intercepts? I mean, we need to find them, but how do we do them? For polynomials, what do we do?
You set the function equal to 0.
So we're going to just take the entire function and set it equal to 0. Now, this is normally the hardest part of polynomial functions, this step right here. And it's the hardest part because this is going to require some sort of factoring. Now, the first step to factor anything is to look for a GCF. So you're trying to find a greatest common factor, something that they all have in common. So because this is a review, I'm gonna kind of work through this a little bit faster. I'm not gonna have time to call on people to get each step done. I'm just gonna tell you what I'm doing. So I'm gonna do a GCF. In this case, I noticed that every single term has an x squared. So I will pull an x squared out. And when I do that, I will have this inside the parentheses. Okay, so I've removed an x squared from every term. Now, what's still in the parentheses needs to be factored. And so you have to know how to factor something like that. So the thing you look at is how many terms you have, right? So how many terms do we have? We have 4 things in there. And since we have 4 terms, we're going to use what's called grouping. We've talked about grouping before. So grouping, what you do, I'm going to do it all on the side here, just so you can kind of see. I'm doing it like scratch work over here. What we do is we slash this thing right in the middle, right after the second term. We just divide this thing out. And then what we do is we look at just the first 2 terms and we see if we can pull a GCF out of just those 2. And what we realize that you can pull an x squared out of just those 2, and you're left with x plus 5. And then what you do is you look at the other 2 terms and you see if you can pull a GCF out of those. And hopefully you recognize that they both have a -9. So I can pull a -9 out and I will be left with x plus 5. So if you were to check, distribute the -9 through the parentheses, you get back what's here. So that's the first step of grouping. Now what we do is, since these 2 things match, all you have to do is write down what matches, just write it down in parentheses. And then in the second set of parentheses, you put the 2 things that were out front. So x squared and then -9. Now, I would say we're really, really close to being done, but there's one more thing we have to realize. And can somebody tell me what it is about this x squared -9 that's special?
It's a perfect square.
It's called what we call a difference of squares. So that also factors to be x plus 3 times x minus 3. So there's a lot of things we have to recognize in this problem. We have to pull out a greatest common factor of x squared. We have to see we have 4 terms, which means we have to go do grouping. After we do the grouping, we have to realize that we actually had a difference of squares. So let me come back now. That's fully factored. Let me come back. I'm going to write down the x squared that was there. All that green stuff is this, right? Everything there is the green stuff. So that becomes x plus 5 times x plus 3 times x minus 3 equals 0. I don't know why I said square. Okay, so there it is. It is fully factored. Now we set each factor equal to 0. And this is going to set up like 4 different equations. So each one of these we set equal to 0. Now for the first equation, the only thing that you can square to ever get 0 is 0 itself. So 0 squared is 0. On this one, you subtract 5 on both sides, you get x is -5. Subtract 3 here, get x is -3. And add 3 here, and you get x is +3. So we have 4 x-intercepts. Now here's the step that you have to figure out the crossing or the touching. Who was that? Was it Abigail who asked that earlier, or was it Beth? I don't remember. One of you.
It was me. Sorry, sir.
No, it's okay. So this is the step. Okay, we know that these are x-intercepts. So we know that these are dots on our x-axis. We just don't know if we're crossing or touching. So what we do is we say, okay, at x equals 0, to figure out if we're crossing or touching here, we go all the way back up to the factor it came from, which was, oh, I went too far, which was that x squared right there. And we look at the power, and the power there is a 2. And since 2 is an even number, even means we touch. All right, so that means that I'm going to touch at this one. For the next one, at -5, I go back up to the factor. Here's the factor it came from. And I look at the power on that factor. Now, the power is not written, so we have to understand that it's a 1. And because it's a 1, 1 is an odd number, that means we're going to cross. And then we do the same thing for the remaining ones. At -3, we come up, where did that come from? Came from here. What's the power on that? Well, it's a 1, and that means we are going to cross. And the last one, same thing. That one came from here. The power on that one is a 1, and that means we're going to cross. Is that clear to everyone? Okay, so now it's time to draw the picture. That's the third step. We want to sketch it. Now to sketch it, what we do is we start by putting our x-intercepts. After we put our x-intercepts, we put our end behavior, and then we connect the dots, all right? So I'm going to put my graph here. Put all my x-intercepts. So let me start. I got 0, there's an x-intercept. -5 over here somewhere, I've got an x-intercept. -3, which is about right there. You don't have to be perfect with this. Just make sure that the numbers are in the correct order, right? So there they are. There are my 4 x-intercepts. And then my end behavior was left side down, right side up. So over here, way at the left, I'm going to just draw like kind of an arrow going down, and over here on the right, an arrow going up. And now I have to just connect all of this together with a nice smooth curve. But here's where I have to use the idea of the crossing and the touching. So as I draw this, I always start at the left. As I draw this, I have to go to this this -5 here. And when I get there to the -5, I've got to cross through. So I'm going to cross through right there. Okay, so just go up above. And now you have to get back to the -3. And when I get to the -3, I'm going to cross through there. So I kind of go up and then I come back down. And then I've got to get to the 0. But when I get to the 0, I'm going to touch, or if you don't like the word touch, you can also use bounce. I like bounce, but you know, whatever. So I'm going to go here and I'm going to just bounce off the x-axis. And then I've got to get to the 3, and when I get to the 3, I've got to cross. So I'm going to cross through, and then I'm going to connect it to that end, and that is my picture. And I already told you this before, everyone's picture is going to look a little bit different. So someone might have something that looks like this, might go way up, way down, bounce. Okay, those answers, even though they look completely different, are both correct. All right, I don't care about how high up and down you go. The key is that you better have the right x-intercepts. Don't add any new ones. Your left and right behavior needs to be correct, and you need to be crossing or touching like correctly. Any questions on that? No? All right. What's next? What do you want me to do?
Did you do number 7?
Number 7. Okay, so we did number 5. Okay, let's look at number 7. All right, so we want to sketch this. Of course, we have to recognize that this is a rational function. It's obvious, yes, that it's rational. I mean, it's a fraction that pretty much like tells you right away. It's it's going to be a rational function. So I'm just going to write up here, it's rational. And let's look at the steps for rational. I know I've got those somewhere here. Oh, there it is. Steps to sketching a rational function. We want to find the x-intercepts by setting the numerator equal to 0. We want to find the vertical asymptotes by setting the denominator equal to 0. We want to find the horizontal asymptotes. And this was the one where we talked about there were 3 different cases of what could happen. And I'd mentioned that, I believe, last time. Right here. This is the step when you compare the degrees. So I'll refer back to that, but I'm just letting you know we've covered this, right? And then after we do the horizontal asymptotes, this is where we put all the information down, draw a picture, and then we have the very important test points. And that will allow you to do a final picture, so we'll sketch it. All right. These take a while, right? We saw that last class. We only did like two of them or something. So let me start off step 1, x-intercepts. And to do that, I'm going to set the top equal to 0. The numerator, right? Now that is a quadratic. So you have really 2 options. You can try and factor it, or you can use a quadratic formula. Factoring is going to be faster, okay? But the quadratic formula will also work. So I'll do it both ways. The factoring, what I would do if I factored is I would take the number in front, I would multiply it times the number in back, that's -24. And then I take the number in front of the x, which is -2. And then I have to mentally come up with 2 numbers that multiply to be this and add to be this. And so I think about it for a little while and I realize that -6 and +4 work. -6 times 4 is -24. And then if you add those 2 numbers together, -6 + 4, you get -2. So those are my kind of magic numbers. And then what we do is we would factor this to become x -6 times x + 4. Now, I've said this from the beginning of this class. Some of you know how to do this and you spent time doing it in high school or some other class and you're comfortable with it. Great. If that's where you are, wonderful. You set these both equal to 0, you get 2 answers. You get 6 and you get -4. Now, if you don't do this, you have to use a quadratic formula, which means you have to use the formula -b ± square root b squared minus 4ac, all divided by 2a. So yes, you should have that written on your reference sheet. I'm not going to provide you with anything, okay, at all. So make sure you have everything you need on that sheet. So you have to, if you're going to use quadratic formula, you need to, determine what's a, b, and c. So for this problem, a would be 1, the number in front of x. B would be -2, the number, 1 is the number in front of x squared. -2 is the number in front of x. And c is the number by itself. And then you have to just use the formula. So it would be +2 plus or minus the square root of -2 squared, which is 4, minus 4 times a, which is 1, times c, which is -24, all over 2 times 1. And this is where I said you count the number of negative signs you see. And since we see 2 negative signs, it's going to turn into a plus. So to become 4 plus, and now you just multiply these numbers together. So what do you get there? 80, 96, so plus 96 all over 2. So 2 plus or minus square root of 4 plus 96 is 100 over 2. I know I'm working fast, okay? Square root of 100 is 10 over 2. So now this is where you have 2 different answers. If you do the plus, that'll be 2 plus 10, which is 12, over 2, which is 6. And if you do the minus, it'll be 2 minus 10, which is -8 over 2, which is -4. And those are the same 2 answers we had if we factored it. So I think you would agree with me that the quadratic formula, although it's nice, is longer and time might become an issue for you on the test. All right, any questions? Jesus?
In that
Sure,
second
I have
step.
Hold
Oh,
on,
sorry.
Jesus first.
Does that say 4 times 4 on the second step?
Right here?
Yeah. Yes.
That's a minus because the formula is a minus. Is
Oh,
that,
okay.
that your question?
Yes.
Okay. Abigail? Abby?
It was just about those 2 questions you gave us like a week ago, maybe 2, for like the extra points.
The bonus? Yeah. Uh-huh.
Does that still apply? Like we just send in a picture when we're done with it?
Yeah, I forgot about the bonus. When you send me your test, you're going to send your work, you're going to send the reference sheet, and then that bonus that I offered, attach that to the back of it also. So if
Okay.
you don't know what bonuses I'm talking about, can't remember what day there they are. Those are the bonuses. So I'll post this video later on YouTube, then you can go and take a look at it if you want to look at these. Okay. All right, so let's continue here. We have the x-intercepts. Now I want to remind you that these are going to be dots on the x-axis. All right, that's what x-intercepts are, right? All right, second step, we want to find the vertical asymptotes. And to do that, we set the denominator equal to 0. Now, this denominator is also quadratic, so we could use the quadratic formula, but you're going to waste so much time if you do that. If you recognize that this is a special form of a quadratic where you're missing the number, you have an x squared and you have a minus 3x, but you don't have a number, the way you solve these is just GCF, just pull an x out. And there, this is much cleaner. You just set each one of those equal to 0. So if you set the first one equal to 0, you get 0. If you set the second one equal to 0, you get 3. I'm not going to show that work, but we have 2 answers. Now, these are not dots. These are not dots on our graph, right? These are vertical barriers. And they're actually not part of the graph. Like these are just vertical lines that we can't cross, right? That forces our graph up or down. All right, next step, horizontal asymptotes. So at this point, this is where we're going to have 3 different things that could happen. So what we have to do is we have to look at the degree of the numerator, which is 2. Okay, I just highlighted that in yellow. So I'm just going to put here num is 2. And the degree of the denominator, which is also 2. So denominator is 2. And so what happens when they're equal to one another? So I'll go back to the notes from last class. To find the horizontal asymptotes, did I put horizontal asymptotes? I never put what we're doing. Okay, horizontal asymptotes is what we're doing on step 3. So what we do is we compare the degree of the numerator to denominator. If numerator is less than denominator, this is what happens. If they're equal, then it's going to be the leading coefficient of the numerator divided by the leading coefficient of the denominator. So LC there means leading coefficient. So that means I need to go back over here. I need to look at the numbers in front because they're equal. I need to look at the numbers in front. I have a 1 and I have a 1. So I'm going to say that y equals 1 is my horizontal asymptote. Any questions? 1 is because I did 1 divided by 1. Right? If this up here had been a 2, be 2 divided by 1, that'd be 2. If this was a 1 and this was a 2, then it would be 1 divided by 2, which would be a half, right? So you have to pay attention. Don't just assume it's 1. All right, now, what is this on our graph, right? We need to understand when we go and put this on our graph, what it is. So this is I called it like a magnet that pulls your graph, right? Kind of pulls the graph to it. But very important, this only tells you what happens at the ends of the graph. So ends only. I can't stress that enough. All right, back to the steps. We've done the x-intercepts, done the vertical, done the horizontal. Now put everything on a graph. Okay, so here we go. Okay, my graph is going to be in blue. All right, I have two x-intercepts at 6 and -4. Those are dots on my x-axis at 6 and -4. Dots. Then I have two vertical asymptotes at 0 and 3. So vertical asymptotes are these vertical barriers. I have one at 3, and so I'm going to draw a dotted line straight up. And I have another one at 0. Now 0 is the x-axis. I mean, sorry, the y-axis. So it's hard to draw dashes. So I did them slightly angled so you could see them. Those are my two verticals. And then I have a horizontal of y = 1. And so I'm going to go up 1, a y value up 1. Here's 1. And over here, way at the edges, I'm going to draw a dotted horizontal line out here that I'm going to remember is a magnet that pulls my graph towards it. Okay, let's see if y'all remember what I said last time. I need to pick test points, right? Can someone tell me how many test points I'm going to have?
3.
3,
5.
5. Any other? Does anyone remember what
I said 4.
4? Does anyone remember what I told you, how you could determine how many you should have?
Didn't
Yeah,
you
how many
just say
points
it
do you
would be
have, Bob?
more than the vertical barriers and the x-intercepts combined?
Yeah, so you count, how many x-intercepts did we have? 2, right? How many verticals did we have? 2, that's 4, right? You don't worry about the horizontal. Don't look at the horizontal for this. You count your x-intercepts 2, count your verticals, that's another 2, we have 4. You will always have one more test point than you have total x-intercepts and verticals. So we should have 5 test points. Now, they can't just be anywhere. They have to be in these different regions. So can somebody give me the first test point that they want me to use?
-6.
-6. Okay, so -6 over here. I'm going to just put -6. I'm going to draw a circle around it. I'm not going to put a dot there. That will take care of everything out here. That'll give us information about that all the way up until we get to -4. Someone give me another one.
-2.
-2. Okay, that should take care of helping us draw the graph between here and here. Another one?
2.
2. Okay, 2 here would give us information about the graph and what it looks like between there and there. You don't need to draw these little arrows I'm drawing. I'm just trying to help you see why we're picking these numbers. We now need something between here and here, 3 and 6. So how about 5? You could use 4, okay? You just can't use 3 or 6. And then we need one more, anything to the right of 6, so I'll just pick 7. And that'll take care of everything else. So we have 5 test points, right? That'll take care of all the regions. I want to get all this out of here because I don't want you to accidentally think that's part of the graph or something. All right, here we go. Now, this is the very unfortunate part, right? Because you have to now take that, each one of those. Oops, I don't want to do that. Why am I doing that? You have to take each one of those and plug them into this. So I'm going to move that down here so I can do that. So that means I have to take -6 and plug it into that function, which means I have to do -6 squared minus 2 times -6 minus 24 over -6 squared minus 3 times -6. And then you just have to be very careful to get this all correct, right? You can't, if you mess up a sign here, it's going to be a disaster. So -6 squared is 36. Okay, -2 times -6 is +12. And then -24. All over, see, -6 squared is 36.